Good morning, children. Today we are going to start lesson number 3, metals and non-metals. There are 115 chemical elements known at present. There are similarities as well as differences in the properties of these elements. On the basis of their properties, all the elements can be divided into two main groups, metals and non-metals. Both metals as well as non-metals are used in our daily life. Here you can see few examples of metals and non-metals are given to you. Okay, nails are made up of iron metals, then copper metal pipes. This cup is made up of silver metal, then bangles are made up of gold. These are metals. So metals are the elements that conduct heat and electricity and are malleable and ductile. Iron, aluminium, copper, silver, gold, platinum, zinc, tin, lead, mercury, sodium, potassium, calcium and magnesium. These are the very important metals. Metals are the elements which form positive ions by losing electrons, okay, or donating electrons. In fact, metals are known as electropositive elements because they can form positive ions by losing electrons. Metals are widely used in our daily life for a large number of purposes. The cooking utensils, electric fans, sewing machines, cars, buses, trucks, trains, ships, and aeroplanes are all made of metals or mixtures of metals called alloys. In fact, the list of articles made of metals which we use in our daily life is unending. Metals are very important for the national economy of every country. The most abundant metal in the Earth's crust is aluminium, which constitutes about 7% of the Earth's crust. The second most important metal in the Earth's crust is iron, which constitutes about 4% of the Earth's crust. Let us start with non-metals. Non-metals are the elements that do not conduct heat and electricity and are neither malleable nor ductile. They are brittle. Carbon, sulfur, phosphorus, silicon, hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, helium, neon and argon. These are few examples. Here in picture you can see carbon, sulfur, then chlorine gas, yellow colored chlorine, non-metal. These are very important non-metals. Non-metals are the elements which form negative ions by gaining electrons. In fact, non-metals are known as electronegative elements because they can form negative ions by gaining electrons. Though non-metals are small in number as compared to metals, but they play a very important role in our daily life. In fact, life would not have been possible without the presence of non-metals on the earth. For example, carbon is one of the most important non-metals because all the life on this earth is based on carbon compounds. This is because the carbon compounds like proteins, fats, carbohydrates, vitamins and enzymes, etc. are essential for the growth and development of living organisms. Another non-metal, oxygen, is equally important for the existence of life. This is because the presence of oxygen gas in the air is essential for breathing to maintain life. It is also necessary for the combustion of fuels which provide us energy for various purposes. The most abundant non-metal in the Earth's crust is oxygen, which constitutes about 50% of the Earth's crust. The second most abundant non-metal in the Earth's crust is silicon, which constitutes about 26% of the Earth's crust. Now, let's start with physical properties of metals and non-metals. Metals are malleable, that is, metals can be beaten into thin sheets with a hammer. Gold and silver metals are some of the best malleable metals. Aluminium and copper metals are also highly malleable metals. All these metals can be beaten with a hammer to form very thin sheets called foils. Metals are malleable and ductile. Okay, let's finish with all physical properties of metals. Second, see, in ductility, metals Aluminium metal or magnesium iron, you must have seen wires, right? The metals such as copper, aluminium, magnesium and iron are available in the form of wires. The property which allows the metals to be drawn into thin wires is called ductility. Gold is the most ductile metal. For example, just 1 gram of gold can be drawn into a thin wire about 2 kilometers long. Silver is also among the best ductile metals. Copper and aluminium metals are also very ductile and can be drawn into thin copper wires and aluminium wires, which are used as electric wires. Metals are good conductors of heat. Metals allow heat to pass through them easily. Silver metal is the best conductor of heat. The cooking utensils and water boilers, etc., are usually made of copper or aluminium metals because they are very good conductors of heat. When a metal is heated, its atoms gain energy and vibrate more vigorously. This energy is transferred to the electrons present in the atoms. These electrons can move through the metal. When the energetic electrons move through the metal, they transfer energy to other electrons and atoms of the metals some distance away from the end that is being heated. In this way, heat is conducted from one end of the metal to its other end. Next property, metals are good conductors of electricity. Metals allow electricity to pass through them easily. Silver metal is the best conductor of electricity. Copper metal is the next best conductor of electricity, followed by gold, aluminium and tungsten. The electric wires are made of copper and aluminium metals because they are very good conductors of electricity. Metals are good conductors of electricity because they contain free electrons. These free electrons can move easily through the metal and conduct electric current. Next property, metals are lustrous. Okay, means by saying that metals are lustrous, we mean that they have a shining surface. The shiny appearance of metals makes them useful in making jewelry and decoration pieces. The shiny appearance of metals makes them good reflectors of light. Silver metal is an excellent reflector of light. That is why it is used in making mirrors. The metals lose their shine or brightness on keeping in air for a long time and acquire a dull appearance due to the formation of a thin layer of oxide, carbonate or sulfide on their surfaces. Next property, metals are generally hard except sodium and potassium, which are soft metals which can be easily cut with a knife. Next, metals are strong. By saying that metals are strong, we mean that they can hold large weights without snapping, without breaking. For example, iron metal in the form of steel is very strong. Due to this, iron metal is used in the construction of bridges, buildings, railway lines, girders, machines, vehicles, chains, etc. Next property, metals are solids at room temperatures except mercury. Mercury is present in liquid state. Next property, metals have high melting points and boiling points. Again, we have exception of sodium and potassium metals which have low melting points. Then gallium and cesium metals also have low melting points. The melting point of gallium and cesium metals are so low that they start melting in hand by the heat of our body. Next property, metals have high densities except sodium, potassium which have low densities. Then metals are sonorous, that is, metals make sound when hit with an object. It is due to the property of sonorousness or sonority that metals are used for making bells and strings of musical instruments like sitar and violin. Metals usually have a silver or grey color, except copper and gold. Copper has reddish brown color, whereas gold has a yellow color. So this is a list of properties of metals. Let's start with the physical properties of non-metals. Non-metals are neither malleable nor ductile. Non-metals are brittle, means break easily. When sulfur or phosphorus are beaten with a hammer or stretched, they break into pieces. The property of being brittle is called brittleness. Brittleness is a characteristic property of nonmetals. Next property, nonmetals do not conduct electricity. Again, we have exception of graphite. Graphite is the allotropic form of carbon. Is the only nonmetal which is a good conductor of electricity. Since graphite, which is a good conductor of electricity, is used for making electrodes. Non-metals are not lustrous, they are dull. Exception is iodine. Iodine is a non-metal having lustrous appearance. It has a shining surface. Non-metals are generally soft. Okay, only one non-metal, carbon, in the form of diamond is very hard. Non-metals are not strong, they are easily broken. For example, graphite is a non-metal which is not strong. It has low strength. So when a large weight is placed on graphite sheet, it gets snapped. Non-metals may be solid, liquid or gases and room temperature. Non-metals can exist in all the three physical states. For example, carbon, sulfur and phosphorus are solid nonmetals. Bromine is a liquid nonmetal, whereas hydrogen, oxygen, nitrogen, chlorine are gaseous nonmetals. Nonmetals have comparatively low melting points and boiling points, except diamond, which is a nonmetal having a high melting point and boiling point. Nonmetals have low densities, that is, nonmetals are light substances. Nonmetals are non-sonorous. They do not produce sound when hit with an object. Nonmetals have many different colors. For example, sulfur is yellow, phosphorus is white or red, graphite is black, chlorine is yellowish green, whereas hydrogen and oxygen are colorless. Okay, this is all about physical properties of metals and non-metals. Let's see chemical properties of metals. Reaction of metals with oxygen. When metals are burnt in air, they react with the oxygen of air to form metal oxides. Metals react with oxygen to form metal oxides. Metal oxides are basic in nature. Some of the metal oxides react with water to form alkalis. Metal oxides, being basic, turn red litmus solution to blue. The vigorous reactions of oxygen depends on the chemical reactivity of metals. For example, reaction of sodium with oxygen. Sodium metal reacts with oxygen of air at room temperature to form a basic oxide called sodium oxide. See the reaction, 4 sodium plus oxygen gives sodium oxide. So this sodium oxide is basic oxide because metal oxides are basic in nature. So we can have examples of potassium with oxygen gives potassium oxide. Then magnesium with oxygen gives magnesium oxides. So these are the examples where metal reacts with oxygen to form metal oxides. But we have some another form of metal oxides called amphoteric oxides. See, aluminium metal burns in air on heating to form aluminium oxide. 4 aluminium plus 3 oxygens gives 2 aluminium oxides. So here one point which is very important, that this aluminium oxide is amphoteric oxide. So what is amphoteric oxide? See, the metal oxide which show basic as well as acidic behavior is known as amphoteric oxide. So aluminium metal and zinc metal form amphoteric oxides. Thus aluminium oxide and zinc oxide are amphoteric in nature. Amphoteric oxides react with both acids as well as bases to form salts and water. Here in this example, you can see how the aluminium oxide is reacting with hydrochloric acid and gives aluminium chloride and water. This is a simple neutralization reaction. As aluminium oxide is reacting with acid, it means here aluminium oxide is having basic nature. In second example, aluminium oxide is reacting with sodium hydroxide and giving salt and water, that is sodium aluminate and water. So as aluminium oxide is reacting with sodium hydroxide, which is a base, it means here aluminium oxide is behaving like an acid. Next example, zinc oxide. Zinc oxide is again an amphoteric oxide. See here in this reaction, zinc oxide reacting with hydrochloric acid gives zinc chloride and water. Yes, in this reaction, zinc oxide is reacting with acid. Therefore, zinc oxide is basic in nature. In second reaction, zinc oxide is reacting with sodium hydroxide and giving sodium zincate and water. So, as zinc oxide is reacting with sodium hydroxide, which is a base, then zinc oxide is acidic in nature. So, this way, aluminium oxide and zinc oxides are called amphoteric oxides because sometimes they behave like an acid, sometimes they behave like an basic oxide. Thank you.